All right. So in this case, I want us to consider a revision exercise that we are going to work on. That is on our geometry of straight lines using some properties also that we need from our triangles and so forth. So we are given in triangle ABC, that is the whole triangle that we are given from A to B to C. Then EF is parallel to BC. So take note here, EF is parallel to BC. That is the line EF and the line BC, they are parallel. So we've got the indication of the parallel lines, remember. Then we are given BC is produced to D. That is, if you take the line BA, this line BA that we are saying, it is being extended to the point D, that it is produced to D. So the question was on number one, calculate A and hence, which means there is a continuation. You have to continue from the value of A that you calculated. So we need the value of A first, and hence show that AE is equal to AF. All right, that's another question. Let's start by finding the value of A. So this is what you are given. That is your diagram there. And in this case, you are supposed to ask yourself like, how can I obtain the value of A with the information that I'm given? Okay, let's consider one. We have got a triangle where the value of A, where A is involved, there is A here. There is also the part of A which is outside of the triangle, this one. So what is the relationship that we can use? Because in order for you to obtain any value that you be given from the diagram, you must form an equation. You must have an equation that you are going to use. Remember, an equation is the one that you solve for a certain value. Meaning to say, if it is A, you solve for A. If it is X, you solve for X. So you must have an equation that you are going to solve so that you are having the letter that you are given there. All right, so the question is, how can we form an equation using this part where A is and also this A that we are given, and maybe with an angle of 80 degrees that is there? How can we form an equation from there? I want you to see it here. There is a property of a triangle that is simply demonstrated there. Remember, in a triangle like this, angles in a triangle, very true, they add up to 180 degrees. We know that. But in this same triangle, the moment that we just extend one line or we just produce one line to another point, what happens is that we form an exterior angle. Remember the concept. You form an exterior angle, which is the one that is outside. Remember, this is short for an angle. That is an exterior angle that you're forming. Inside of the triangle, you'll be having the interior. All right. So there we're going to have the interior angle. So what happens? Remember the relationship. If this is A and this is B, these are opposite interior angles. So let's say our exterior angle is C. It follows that this exterior angle is equal to the sum of these opposite interior angles. Thus, A plus B is equal to C. A plus B, the interior angles, equal to the exterior angle. So thus, in this case, is it the same condition that we have? Because there is an exterior angle, so you're supposed to think about that. There's an exterior angle here. This is the interior angle. B is the interior angle, not the one that we want. We want the ones that are opposite to the interior angle, which is the 2A and the 80 degrees. So forming an equation, we are going to take the 2A and the 80 degrees. 2A plus 80 degrees, the opposite interior angles. They must be equal to the exterior angle. So we equate these ones to our exterior angle. And what is our exterior angle? That is 5A minus 40 degrees. So we are going to equate this to 5A minus 40 degrees. What is it that you have? An equation. you have formed an equation that you are supposed to solve. So take note, you need the opposite interior angles, these opposite interior angles. You add them, they must give you the exterior angle. This exterior angle, this one, is equal to the sum of these two, just like that. So you see, there we have to apply the properties that we know about the triangles. So we need that in our geometry of straight lines. So we have an equation. Let us solve for A. We can take, remember, the issue of collecting like terms. So we can take the 5A to the other side so that it's going to be a negative 5A. It was a positive, so it will be 2A. The 5A to the left-hand side, it will be minus 5A, which is equal to, already there is a minus 40 degrees on the left-hand side. So that is going to be minus 40 degrees. We take the positive 80 to the other side. Remember that the number, the moment it crosses the equal sign, it changes its sign. So if this was a plus, it is going to change to a minus. So that's minus 80 degrees. So we have an equation that we need to solve, collected the terms, part of A, the constants on their own, which are the angles on their own. All right, so let's solve. 2A minus, so here, okay, the reason here is going to be the exterior angle. So I'm just going to write in short, exterior angle is equal to sum of opposite interior angles. Okay, so I'm just going to write in short. So that's the reason that we used here to obtain this equation that we need to solve. All right, 2 minus 5, that is minus 3. You can even use your calculator there. 2 minus 5, that's minus 3, guys, okay? Minus 40, minus 80, that will be minus 120 degrees. So we can divide by a negative. Remember from our equations, I talked about that. The product, divide by negative 3, which is multiplying. So we divide by negative both sides. So that is, we are going to obtain the value of A. So that's a negative, negative cancels, and that will be 40 degrees. You can even use your calculator straightforward to divide that. You're going to obtain 40 degrees. So that is the value of A, meaning to say, wherever we see A, we can substitute the angle that we obtained of 40 degrees, just like that. All right, let's see another question. Remember, there were two questions here. To calculate the value of A, and that's a and, hence show that AE is equal to AF. Show. They are not saying they're equal. You are supposed to show that they're equal. You are supposed to prove. To show, that is to prove. You do not know that they are equal, but you're supposed to prove that they are equal. AE and AF. All right, let's check on our diagram where AE is. We need to prove that is, in this case, the second part is to prove that, or to show that AE is equal to AF. Okay. How can we show that AE and AF are equal? This is our line AE, and this is our line AF. They are not equal for now, because if they were equal, they were going to put this to show you that they are equal. Now you are the one who is supposed to show that this line and this line, they are equal. You are supposed to show that. Okay, just refer to the normal thing that you know on a triangle. When the two lines are equal like this on a triangle, let's say we've got a triangle like this, and we've got two lines which are equal like this. What is it that we know? That is the one that we are going to use to prove that they are equal. We do understand that if these two lines are equal, the angles that are opposite these sides, this angle here and this angle that is opposite this side, this angle and this angle, they are supposed to be equal. So we know that the opposite angles are also equal. Opposite, the ones that are, okay, so let me just write this way so that you understand, because if I write this, guys, and you write this reason like this, you might be disqualified for not writing properly. So we can just write this in a proper way like this: angles opposite. Okay, equal sides. Equal sides are equal. So these angles that are opposite, the equal sides must be equal. This angle and this angle must be equal. So using that way, we know that it's a property that you need to know of a triangle. It's a property of a triangle that you need to know. So if we are to prove that, if we are to show that, because they are saying this line AE and AF, we need to prove that they are equal. So the only way for us to prove is to show that this angle opposite, which is 80 degrees, and this also angle opposite, which is 2A, they are equal. If these two angles, these ones, if they are equal, there is no way these sides will be equal also. That's how we are going to prove. So we are simply going to substitute the value of A. Remember, we got that A is 40 degrees, all right? A is 40 degrees. So let's start by angle AEF. Angle AEF is given as 2A, and we obtained that A is 40 degrees. So 2 times 40 degrees is equal to 80 degrees. Already here, we are given angle AFE. Angle AFE is already given, which is 80 degrees. We have this angle. Guys, there is no way that these two angles will be equal. That here will be having an angle of 80 degrees and these sides are not equal. No, there is no way. Once these angles are equal, it follows that the sides opposite these angles must be equal. So we oppose this way. Remember, from the sides, we say angles opposite equal sides are equal. Now we are stating from what? From angles. We saw that the angles are equal. So it means the sides opposite equal angles are equal. So that will be the reason that we are going to use in that case. There is no way, guys, these two must be equal. So therefore, AE is equal to AF. These two, they are equal. So the reason, like I'm stating here, will be that sides opposite equal angles. So these are sides opposite equal angles. So definitely these sides must be equal. So that means from A to E and from A to F is going to be equal. Just like that. So that was our question number 1 in all this part, and also to show that or to prove that those two are equal. All right, let's move on to another question, which is the last part of our question, question 2. Calculate with reasons the value of B, C, D, and E. So they will need reasons to calculate all these angles that are remaining, angle B, angle C, all these angles that are remaining. Remember there we have already calculated angle A, and like I said, you can also substitute the value of A that you calculated so that you can be able to calculate those remaining angles that we are given. Already we substituted this value of A here, and we said the angle AEF is 80 degrees. This is 80 degrees. What is it that we are forming here? We have got a triangle. All right. So we do understand that angles in a triangle, they add up to 180 degrees. So that means we can calculate the value of B by subtracting these two angles from 180 degrees. So B is going to be 180 degrees minus these two angles that we are seeing inside of the triangle. We remove them from 180 since all the angles in a triangle add up to 180 degrees. There we are talking about triangle A to E to F, like that. This is the triangle that I'm talking about. So we can use that. So the reason there will be angles in a triangle. All right, so you can use angles in a triangle. So there I'm just writing in short, angles in a triangle, like that. Okay, so let's solve for B. That means B will be equal to what? So there you just need to subtract from your calculator straight 180 minus minus 80 minus 80. So that was going to give us 20 degrees. All right, so that was another way that you could have used, or you can calculate this angle, that is the exterior angle at A. If you can use that, then you use the concept of angles on a straight line. So that's another way that we could have calculated the angle B. We could have calculated this angle that is outside of the triangle DAC, the exterior angle that you are given of 5A minus 40. All right, so we're going to calculate that exterior angle first. I'm just going to write in short, guys. Exterior angle is equal to 5A minus 40 degrees. And we obtained A. Remember our A, when we calculated it, it was 40 degrees. The one that I removed there, it was 40 degrees. So it's going to be 5 into 40 degrees minus 40 degrees, like this. That means the product of the two, that's 200 degrees minus 40 degrees. So 200 minus 40, that is 160 degrees. So we are going to subtract the 40 degrees and obtain 160 degrees. Remember, this is the exterior angle that we are talking about. We are talking about this angle here, outside this angle that is outside here, which is 160 degrees. So if this angle is 160 degrees, how can we calculate the angle B? We can now calculate the angle B from the angles on a straight line. These are adjacent angles on a straight line. So B is going to be 180 degrees minus 160 degrees, meaning to say B will be 20 degrees. So that's another way that we could have used to calculate the angle B. As you can see, we have got the same answer of 20 degrees. So the way that you're going to calculate thereafter, it is in your hands. It is up to you the way that you are going to calculate, as long you are using the geometrical concepts that you understand. So there we have got our angle B, 20 degrees. All right, let's move on to another part. We need B, also C, and these other angles. All right, what about angle C? Angle C, we can simply see that there we have got two lines which are parallel. And in this case, we are forming an F. Look here, there is an F that we are forming here. Okay, that is an F like this. There we are forming an F. Remember, what's the concept? If these two lines are parallel, this angle and this angle, they are equal corresponding angles, the one that form an F. They are referred to as corresponding angles. So meaning to say angle C is equal to 80 degrees. So C is equal to 80 degrees. There we are talking of the corresponding angles. I'm just going to write in short, corresponding angles, since EF and BC are parallel. Since EF is parallel to what? To BC. Remember, these two, they are parallel. So we talk of the corresponding angles. And that same concept actually was going to affect, on this other hand, remember there to calculate here. This is also F that we are forming. So angle E and 80 degrees, they are also equal corresponding angles. So E is also equal to 80 degrees. There we have got the same reason of the corresponding angles. So that is 80 degrees here. Remember, we said C is 80 degrees. All right. So what about D? We can calculate D straightforward. This is a straight line, angles on a straight line. So that means D was simply going to be 180 degrees minus 80 degrees angles on a straight line. So we subtract the 80 degrees from 180. That was going to give us what? That was going to give us 100 degrees. So the reason of this D, we are simply talking about angles on a straight line, angles on a straight line. So these are angles on a straight line. Remember that angles on a straight line add up to 180 degrees. So that means we have got our angle D being 100 degrees. So actually, that is how we could have attempted these typical questions. There are so many ways that we could have used. Also, to calculate D, we could have used this concept. Remember what I said about a triangle and its exterior angle. If you check from A, if you extend this line like this, in this triangle like this one here, in this triangle AEF, you could have calculated the same D, because this D here becomes the exterior angle. Remember the concept of the exterior angle. So this D, the exterior angle, must be equal to the sum of the opposite interior. This is the interior, this one. But the opposite interior, which is the 20 and this 80, must give us D. So 20 plus 80 is equal to 100 degrees. So still, you're going to obtain the same value of D like this one. So this is from the exterior angle being equal to the sum of the opposite, like this concept that we used here. So as you can see, there are so many ways that we can use to attempt these typical questions. All you just need is to work on more revisions as much as you can, and make sure that you also join the membership family so that you'll be revising with us questions like these ones. We're gonna have this question on membership, so make sure that you do join the membership level for grade 8 to 10, grade 8 to 9. I mean, yes, that membership of 8 to 9, it will allow you to have access to other videos to come. So that is what we had, guys, from Maison African Motives. Till we meet again.